Alright, good morning friends. And now we start with a new concept. The concept of PERT, Performance Evaluation and Review Technique. Just have a look. PERT, Performance Evaluation and Review Technique. A very fundamentally important management technique for project management. Basically this was developed, just a 2-minute history, in the year 1950 for Navy purposes by D.G. Malcolm, J.R. Roseboom, C.E. Clark and Mr. W. Fraser. So these were the gentlemen who developed this technique of PERT and is now being used by the companies worldwide. Now what exactly is PERT? So we have understood something called as CPM, critical path method. Now we are moving on to PERT, performance evaluation review technique. When I speak of CPM, it is a deterministic model, whereas when I speak of PERT, it is a probabilistic model. So what is the difference between deterministic and probabilistic model? In deterministic model, in CPM, we have seen that the activity duration is almost fixed for every activity. So there is a clear picture as to what duration a particular activity is going to take. Accordingly, I design my project and also decide the sequencing of activities, allowing me to ensure that the project is started on time and completed on time. As far as PERT is concerned, it is more of a probabilistic in nature. When I speak of probability, there are three kinds of probabilities that are attached to PERT. So CPM is majorly used by companies which have done the similar kind of projects to a very large extent, whereas PERT as a technique is used by companies wherein they are venturing into something new projects, wherein they are not sure of the time duration that the activities may take, and that is where PERT assumes that there is a probabilistic nature in the completion of activity. So probabilistic. So now what is probability? Probability is chance of completion. When I relate that to PERT, when I relate that to a concept of CPM PERT, chance of completion in a particular number of days. CPM it was clear that the activity 1 to 2 is going to take 5 days, activity 2 to 3 is going to take 7 days, activity 3 to 5 is going to 8 days. In PERT, there is a probability, a threefold probability that has to be evaluated. Everybody, there is a threefold probability that has to be evaluated. What exactly is this threefold probability? Pay attention. Now, just take an example of your studies. You all have cleared IPCC, you have reached CA final. Suppose now you are studying for your CA final examinations first attempt. When you are studying for the first attempt, are you sure as to how much time duration you are going to take for a particular subject? The answer is no. You will make a probability. Let's take an example of a subject, law. So I will take a law as a probability that law as a subject will be completed minimum in 5 days, maximum in 12 days, and approximately in 8 days. Try now linking this with PERT. When I speak of a subject law, I plan to complete either in minimum 5 days, maximum 12 days, or approximately 8 days. What am I doing? There is a probability that my whole law portion of CA final will be completed in 8 days, in 5 days. There is a probability that my whole portion will be completed in 12 days. There is a probability that my portion will be completed in 8 days. First is the best time estimate. First is called as the optimistic time to complete law. Second, 12 days is called as the pessimistic time to complete law. I hope we are understanding. And third, which is 8 days, is the most likely time to complete law. So for completing law, I have 3 time estimates based on my assumptions that law as a subject can be completed TO, also called as optimistic time. So optimistically, I will complete the whole subject in 5 days. Pessimistically, called as TP. So this is called as the pessimistic time. Pessimistically, the whole project will be completed in 12 days. Whereas most likely, chances are that my project will be completed in 8 days. So here there is no certainty. Why? Because I am probably giving it for the first, I am giving my CA final attempt for the first time. So I am going to study law for the first time, and if I am going to study law for the first time, I am not sure as to how much time it is going to take. Same is the case with PERT projects. The PERT projects are those projects which are relatively newer. So the project manager is not aware whether he is going to take 5 days, he is going to take 12 days, or he is going to take 8 days. So he comes out with a probability that he may take 5 days as an optimistic time, he may take 12 days as a pessimistic time, and he may take 8 days as a most likely time. So that is where we say that PERT is probabilistic in nature. Whereas in case of CPM, the duration was fixed. So God forbid, but if there is a second attempt, now I am sure that law, in order to complete whole law, it will take me 9 days precisely. In order to complete costing, it will take me 8 days precisely. In order to complete DT, it will take me 10 days precisely. So probably when we are done with the same projects time and again, that is when we become deterministic for the same, and that model is called as the CPM model. Whereas in case of newer projects, when things are yet not clear as regards time duration, we call that as a probabilistic model called as the PERT model. I hope things are clear till here. Right then, so we understand that in order to complete a particular activity, as far as PERT is concerned, there will be 3 time estimates available with me. One, TO, optimistic time. Second, TP, pessimistic time. Third, TM, most likely. Unlike CPM, where there was only one time duration which was given for a particular activity. So as I said, it is a deterministic model. But as far as PERT is concerned, we say it is a probabilistic model because there are 3 time estimates, of which there is a probability for TO, there is a probability for TP, there is a probability for TM as well. So sir, which one do we choose? We choose TO, TP, TM. Well, based on all of these 3, we will now calculate a new time estimate which is called as PE, expected time. Yes, this is the time estimate that we are going to use in order to draw a network diagram as we used to do in CPM. So sir, how do you calculate this expected time? Well, yes, that is where comes this probabilistic model. And if you all know, for a probabilistic model, there is a normal distribution curve. What is this normal distribution curve? So normal distribution curve basically gives a probability of various time intervals and ranges of the time estimates that we have. So just take an example here, and then we'll just derive the formula for TE, expected time. So now if I draw a normal distribution curve, this is how it resembles. So multinational companies, just to share some things with you, multinational companies throughout the world use this probability distribution table, which they also call as a bell curve, is used by majority of the HR managers in order to rate their employees. Just take an example. Here, employee 1, employee 2, and employee 3, or rather employee 1, employee 2, employee 3. For obvious reasons, this is where and this is where the minimum number of employees are there, whereas a major chunk of employees are here. As a HR manager, there are three kind of ratings that are probably given to the employees. I've worked with a multinational company for more than 3.5 years, so just sharing a small experience with you. So here there are three kind of employees which are there. One employee gets something called as a needs improvement. The other employee, this is called as NI. The other employee gets something called as meets expectations, called as ME. Whereas there is a third employee which gets the third rating, which is called as exceeds expectations, which is called as EE. So here three estimates wherein the employees fall. There are, say for example, 100 employees. So there will be a case of say 10% employees which fall in the category of needs improvement. There will be a 10% category of employees which fall in the category of exceeds expectations, and there will be 80% category of employees which fall in the range of meets expectations. Now correlate this with the time estimates that we have. This is your TO, optimistic time. This is your TP, the pessimistic time, and this basically is your TM, the most likely time. Utilizing this normal distribution behavior, we will be able to calculate something called as PE, which is the expected time, which will be used in order to draw my network diagram and give the duration as required. So here TO, if you see, has a small chunk. There is EE, which is TP, which carries a small chunk, and then there is ME, which has the major chunk of activities, and that is where the formula for TE, expected time, is derived, which says that TE is equal to TE, which is expected time, is equal to a part of TO, a part of TP. So one part of TP and one part of TO, plus if you see that majority of the numbers will fall here, majority of time duration will fall here. So expect most likely time has a higher chance of being called as a expected time. So that probably has a 4 times chance than TO and TP, and this will then be converted into a weighted average, giving me the formula for TE, which is TO plus 4 TM plus TP upon 6. So no need to learn. What we'll do is, this is how we derive that yes, needs improvement, not many will come here. Exceeds expectations, not many will come here. Meets expectations, majority will fall here in terms of employees. So what is exceeds expectations? You were given a particular task, you did it brilliantly well. So you were given a task to complete it in 10 days, you did it in 6 days, giving even more better quality. What is meets expectations? You were given 10 days, you completed it in 10 days. And what is needs improvement? As far as employee is concerned, you were given 10 days, you took more than 10 days, and the quality of the work was also not up to the mark. So that is where the HR managers rate the employees, and this is where we use that fundamental in our rating as far as calculation of TE is concerned, which is my expected time. So TE will be a combination of TO, TM and TP. So TO plus 4 TM plus TP is equal to 6, and this TE, based on this, we will get the time duration, which we will call that has a chance of 50% completion in the time duration that is being given. So what am I trying to say? Now, based on this estimate, say there is an activity 1 to 2, there is an activity 1 to 3, there is an activity 2 to 3, and finally there is an activity 2 to 4. There are 3 time estimates that I have: TO, TM, TP. Based on these time estimates, I will be able to calculate TE. 1 TO plus 1 TP plus 4 TM divide by 6 will give me TE. Once I get this TE, I will be in a position to draw the project network diagram. I will be in a position to draw a project network diagram. And when I complete this project network diagram, I will get a critical path based on the various paths that are there. The critical path that I get will have a 50% probability that it will be completed in the given duration that we have calculated. So project duration will give me the critical path. The critical path that we get based on a time duration of TE, the critical path that we get based on a time duration of TE will have a 50% completion probability. So suppose that critical path comes to 25 days, there is a 50% chance that the project will be completed in 25 days. 50% negative, 50% positive. So there is a 50% chance that the project will be completed in 25 days based on this probabilistic table. Alright everybody, so again I am just repeating. So performance evaluation review technique basically tells me that there are 3 time estimates which are given: TO, TP, TM. TO is your optimistic time, TP is my pessimistic time, TM is my most likely time. Based on this I will calculate TE. So how do you calculate TE? TE will be basically a combination of optimistic, pessimistic and most likely time. The chance of most likely being 4 times higher as compared to optimistic time or a pessimistic time, and hence the formula TO plus 4TM plus TP upon 6 will give me TE. Based on this TE I will get project duration for all the activities that are there in the project. Once that is done, I will get the critical path for that particular project, and once I get that critical path, I will say that it has a 50% chance of being completed in the time duration that my critical path is trying to give me. So that is how the whole fundamental of TE works, and we will be able to complete the critical path based on this. I hope we are clear. So now that we are clear with the understanding of TE, which basically is my expected time, I will hereby conclude that TE is equal to TP plus 4TM plus TO plus 4TM plus TP upon 6. This basically gives me my TE. So now how does a PERT analysis work out? Pay attention. So first what we are going to do, yes, we are going to calculate the TE based on the 3 time estimates which are given: TP, TO, TM. Then next thing that we have to do is calculate the critical path, obviously taking TE as the base. So our base will always be TE, which we have used for calculating our critical path. Once that is done, what we will do is, because now we have a probabilistic nature of our time duration of activities, there will obviously be some variance which is associated with it. So usually whenever there is a probabilistic table that is there, you will always find a variance. So here we will also have to calculate the variance of each activity. So how do you calculate variance of activity? See, the variance is basically on account of TO and TP. If you clearly observe, when you start doing sums, then the TE will be more skewed towards TM. So chances of TE being very much closer to TM are very high. So variance will be on account of TP and TO, that's right. So that is what my variance is. So my variance will be TP minus TO upon 6 the whole square. So this is how I will calculate the variance of activity, and that will obviously lead to the calculation of standard deviation. So standard deviation, what I will do is, standard deviation will be a root of variance, but variance of critical path. So here when I calculate my standard deviation, I will calculate the standard deviation for the critical path. So how do I do that? It will be a root, square root of variance of critical path that is there in the question. So here, how will I calculate the variance of critical path? Using Tp minus To upon 6 the whole square as a formula, and based on that I will take a root of that and I will get a standard deviation. Now how does a PERT methodology help? PERT methodology helps to calculate the percentage completion time, percentage completion probability for a given time estimate, for a given time estimate. Now we all know that PERT is a probabilistic table. So whenever we will get the critical path, it will have a 50% chance of being completed in that particular time duration that we've got of critical path. What if the time duration is increased? What if the time duration is decreased? Then obviously there will be a increase or decrease, as the case may be, in the percentage completion as well. Let me give you an example. So suppose there is a critical path, of 21 days. Based on this, now I want to calculate that. So now obviously this 21 days will have a probability of 50%. What does this mean? This means that the project will be completed in 21 days has a 50% chance, a 50% probability. So there is a 50% chance, there is a 50% probability that the project will be completed in 21 days. This is what your PERT CP critical path says. Now there can be two time estimates. Suppose if I am asked that what if we are giving you 23 days or what if we are giving you 19 days. So here, if the duration is increased, tell me the chances of the project being completed in that particular duration will increase or decrease. For obvious reasons it will increase, because जब 21 days मेरे को दिया था तो 50% चांस था, अब मेरे को सेम काम कंप्लीट करने के लिए 23 डेज दे रहे हो, तो ऑब्वियसली चांसेस आर गोइंग टू इंक्रीज दैट मेरा ये टाइम ड्यूरेशन में कंप्लीट हो जाएगा. अगेन वील गो टू आवर बेस एग्जांपल ऑफ लॉ. लॉ में मेरे को पता है कि मेरे को 19 डेज लगने वाला है और वो 19 डेज में मैं कंप्लीट कर दूंगा, उसका चांस है 15%. So there 50%. So there is a 50% chance that I will complete my law portion in 19 days. If instead of 19 days now I am given 21 days to complete the same, if instead of 19 days now I am given 21 days to complete the same portion, obviously the probability to complete the same will increase. Come back to this example. I am given 21 days to complete my law portion. If there is a 50% probability that my law portion will be completed in 21 days, obviously if I am given 23 days, the chances of the project being completed will obviously be more than 50%. Vice versa, if I was given 21 days and I had a 50% probability and now I am just given 19 days, obviously the probability of project completion is going to decrease. So here I may get a 80% probability, higher than 50%, because number of days have been increased. But if my number of days have been decreased, this 80 may even decrease to say 30% as compared to my 50%. Because duration increases, chances increases, because now I have more time to complete the same work. Duration decreases, chances decreases, because now I have less time to complete the same work. And that probably will help me analyze whether I will be able to complete the project in a given time duration, in increased time duration, in decreased time duration, and with what probability I will be able to do that. And that is what PERT as a concept of management technique is going to help me. Any questions? Please feel free to ask. So PERT, a probabilistic model used to analyze the percentage of time completion for a particular project. For this calculation of PERT, we will be given 3 time durations for a particular activity. TO called as the optimistic time, TP called as the pessimistic time, TM called as the most likely time. These are the 3 things that we have. Based on this, we will calculate TE, called as the expected time. This expected time will be calculated as TE is equal to TO plus 4TM plus TP upon 6. Based on this TE, we will draw the whole project, taking TE as our duration of all activities, calculated individually using this formula. Using this, we will find out the various paths which are there, and for these various paths we will calculate the critical path, the path with the longest duration. So this will be the path with longest duration. So our project will be completed based on critical path, which is my longest duration. Moving on. Once we are through with that, we will come to know what is my critical path. For critical path, I know the chances that it will be completed in this point in time is 50%. The chances that the whole project will be completed as per the time duration given by critical path is 50%. Then I will be given certain possibilities, either more than the critical path duration or less than the critical path duration. More than the critical path duration, less than the critical path duration. If it is more than the critical path duration, then obviously chances are that for the project will be completed with a probability which is higher than 50%. However, if I am given a lower project completion time, then in that case it will be less than my 50% time that I usually will take. How do you calculate that? For that we will require two fundamental things. One is the variance, the other is my standard deviation. Variance I will calculate for each activity, because my question at times asks to calculate variance for each activity. How do I calculate variance? This variance is on account of my TP and TO. So TP minus TO upon 6 the whole square. Then I will calculate standard deviation, but standard deviation, which is also TP minus TO upon 6 the whole square, but root of only, see this is variance, so it is a root of variance, but variance of only critical activities is called as my standard deviation. So only critical activities are to be taken into consideration while calculating the standard deviation. Then using my last formula, which will be a probability distribution, based on a probability distribution, will give me my Z, which is the percentage of time completion, which is given duration minus expected duration, my critical path, upon standard deviation, variance of my critical activities. And this is how I will solve a sum based on PERT, performance evaluation and review technique. With this background, let us now move on to solving of practical sums relating to PERT. Thank you.